this one. There we go. Hide that. And where's my slides? There we are. Okay, I think I got everything. Yeah, she's cute, isn't she? That's Lottie, my granddaughter. Lottie's first birthday was on Saturday. She's a cute little kid. Uh, I had to wait a long time before I got a grandchild. But anyway, she's actually in the next room right now. Uh, my daughter and granddaughter both came over for a visit. Anyway, let's get on. We got work to do, and I'm going to try to keep the class shorter today. A variety of administrative things, and that people have been, I am continuing to get a lot of emails about the grades that are showing up in the grade book, showing up that you only got 12 or 14, and that doesn't look good. And it says out of 24, but actually that's out of the 16 points for the multiple choice question. So if you got 14 out of 16, you did pretty good. That there are still some that didn't do all that well, and concerned about them, and I'll be probably following up with them. So multiple choice Top Hat will grade automatically as you do them. The others are the short answer questions. I have to go in and manually grade those. And I spent the weekend trying to figure that out. I finally discovered this morning how to do it. So I can get on working at that now, and I'll try to get them graded as quickly as possible. That just scanning what's in gradebook for the multiple choice, the grades generally look quite good. And so I was pleased on that. But still, there were some folks didn't do the test. I've got quite a number, that didn't do quiz number 3 on Saturday. So I'm a little bit concerned about what's going on, and I've spent yesterday making up my hit list of who I'm going to get after. It's quite a long list, so it's going to take me all week to get after them, but I'd like to know what's going on. I have no objection to having a class where everybody gets an A. If you earned it, then that's great. But I don't like students doing poorly in my classes, and I'll take some responsibility. It's a joint responsibility. You got to do your work. I do mine, but I would prefer seeing everybody do well. So if you're not active, don't be surprised if you start getting emails from me. With quiz 3, at the moment, I'm still giving participation points for the quiz. So you get half a point for trying the question and half a point for getting it right. So you should be able to get 5 out of 10, even if you guessed wrong on every question and you get 2 guesses. You should be able to get 7, at least, on the quizzes, just by guessing. So I don't know why people aren't spending the few minutes to do that. What's the difficulty here? So I'm going to give you a hard time on it. And I've got a couple students have sent me questions about assignment 1. It's good to see people have started it. And if you've got questions about assignment 1, we can start out today trying to deal with those and see if I can't try to answer them through the chat or verbally. So if you've got questions, please ask them in the chat. The most common question I'm getting has to do with an error. Well, there's only one student has actually brought it to my attention, but I expect others will be getting it. At the end of the assignment, you have to do a histogram. And we did those in class. We select that column of data as our input range, and we had no trouble building the histogram. But you may encounter problems with your data set in doing it. And it all has to do with confusion in Excel about how it sees blanks. blank should be blanks. It's an empty space. Isn't an empty space an empty space? No, not when it comes to numbers. That sometimes Excel thinks that it's text. It's a blank piece of text in there. Now, we did encounter that when we recoded gender and we recoded a blank as a blank. We ended up taking an empty cell and converting it into a text blank. And that's what's happening, I think. Because it took me forever trying to get that student's spreadsheet to work. I found a workaround. I copied the column into a new sheet, pasted it into the new sheet, and then did the analysis, and it worked. I went back to the original afterwards, and I sorted it or filtered it, so I just was looking at the blank values for this was for summer earnings, the students that didn't report any value. And then I took all of those blanks and I hit my delete key. So I deleted a blank, which gave me a blank. But then I went back and then asked, okay, do a histogram for me, and everything worked smoothly. So it must have thought before that that empty cell actually had something in it that you couldn't see. So um, Excel can be incredibly frustrating, and trying to find the source of the error is tedious. If you are encountering errors in Excel, or Excel is not doing what you thought it should do, try a few things. If you're still unsuccessful, stop trying. Just email me the spreadsheet and I will look for the answer for you and see what the problem is or what the workaround is, because it's unlikely in many instances you'll spot it. That with respect to submitting your assignment, you'll see on Top Hat that assignment 1 appears 3 times, but once for section A, once for B, once for C. It's all the same assignment. I just want you to submit it in your section so that I will get 3 groups of submissions. Don't submit it to each one, just submit it once, but hopefully to your section. If you made a mistake and submit it to the wrong section, then just leave it. Don't submit it twice. But I've got 3 TAs that will be marking assignments for me. And so that I can split up their workload appropriately, I need to be able to split up that set of assignments for them to grade. And that's the way I'm going about setting it up. It creates confusion in gradebook, but we'll sort that out. It's not important. Um, but so do you have any questions about the assignment? Anything else at this time before we get going? You're free to ask me questions on absolutely anything before I start the presentation. And you can ask them during the presentation, but if you've got questions, I can try to get those out of the way early. It says Victoria is typing. There it is. So in gradebook, it looks like the sample test gave you 1 out of 4. Yeah, it shouldn't have given any points. The sample test should be giving you a 0. It has to do with help I was getting from Top Hat in getting that sample test to work. And I think by accident, one of the questions was given a point value. So it shouldn't have given any of the questions a point value. But don't worry, the sample test is not part of your grade. I'll try to get that cleaned up. Unfortunately, everything goes into gradebook. Anything else? Ryan is typing, it says. We'll give him a second. Is Ryan typing a long message, or is it just not coming through? There it is. Discussion points. So The only way I can launch discussions is to put them as a graded activity, and I'm putting them forward with 0 points. I forgot to post one for this week. I should create another one. That I do want to try to engage people in conversation, so I've embedded some in the PowerPoint for during class, but like the first two that we used, they're sort of broader types of questions, not technical issues. And I've got to try to find good questions that have to do with data in everyday life, because we see it all around us. And I just want you to reflect upon those sorts of things. Reflect upon um, how you may be seeing course material around you, but you don't quite see it. That past students had encouraged me to put discussions into the course, and that because online courses, hard to keep yourself engaged. And so, oh, Lottie's waving goodbye out the window here. Said I'm looking out a window as I work at home. I'm back in Halifax. So I've said I'm going to put some point values on discussion. I've got to find a way of grading that. I'll be doing that in the next 2 weeks or so, coming up with an interim grade, because say Top Hat has recorded everything that you've contributed to the formal discussions. Chat's a little trickier because I don't see that your proper names all the time with that. I think just see your first name. But I'm going to try to give you some feedback on your participation, and that if you're giving a lot of feedback and you're very engaged, that grade could replace your worst test score. But I'm going to give you some more feedback on that halfway through the course. But if you never participate, that's up to you. It doesn't hurt your grade any. But if you are engaged in the discussion, it may help you if you end up with a really awful test along the way. But, anyway, let's start going with today's stuff. So last time we started trying to summarize our data, and we looked at it like summarizing it into groups, trying to get a sense of what's a small number, what's a big number, what's a middle value, and how to communicate that. Do we communicate in a table, frequency table? Most people like looking at pictures rather than tables of numbers. And even tables of numbers, many find difficult to understand as frequencies. We'll be seeing a lot more of that actually next 2 classes, summarizing things in tables and trying to show it graphically. And so that's going to be a big focus of our next 2 classes. And making mention that the table row in Excel is useful for looking up simple summary measures. And today we're going to be looking at them in a more formal fashion, more traditional fashion, should I say, instead of just using a table row. And so last class and this one is more traditional summary statistics, descriptive statistics that you would see in a stats course. But the subsequent 2 classes are going to be looking at these things using a much more powerful tool, and one that is quick and easy to do an awful lot of things. Should be taught in a stats course. Anyway, let's move on. So we're going to look at numeric measures. So instead of just summarizing things and making a table or making a chart to summarize information, are there a couple of landmark values, specific numbers that do a better job at conveying information and doing it quickly just with numbers, without pictures? And so if I gave you, if you did have the proper test grades back, I expect some of you would be asking me, well, what was the class average? Because you want to know, are you above average or below average? And if you're an average sort of student, got if in the end the class average was 70% and you got 72% on a test, you'd say, oh, okay, that's good. I'm happy. But if the class average was 70 and you got an 80%, you'd like to know, that's good. Is it really good? Or did lots of students do better than me? If you only got a 55%, you would like to know, oh, that's really low. But were there others in the same sad situation I'm in? You'd like to know how you did relatively, not just where the middle is, but you're going to want to know how much above the middle and how much below the middle you are. But first off, we've got to define what's the middle. Who's the middle of the class? If you are middle income, what does middle income mean? What does middle? And the most common measures of that are the mean and the median. So the mean is what most of us think of as the average. And I normally would say they're interchangeable. So if you see in Excel a function to calculate average, that's the mean. And so the way it's calculated is, so with the data that we had last class, we had 752 values for salary. So if I took that salary column, added up all those salary figures, and then divided by 752, I would get what the mean is, what the average is. And the average is $52,914.76. Most of the time, I'm not worried about, students will ask me, well, how many decimals should we carry? If it was a number like this, I'd say, why are you even measuring decimals? That the answer is around 53,000. And for most of us, that's as accurate as we need to be. Most of the time, we're not trying to zero in on a specific number. So don't stress on that sort of precision. Now, when you're calculating this average or this mean, you're going to use every number that's there, and each of the numbers is equally important. So every student's answer is equally valid in our calculation of the mean. We don't give some more importance than others. Sometimes with averages, it's beyond the scope of this course, we give some figures more importance than others. A common approach when looking at averages of data over time is if I was looking at average sales per week, trying to predict what sales will look like next week, my best guess is what sales were like last week, because next week will probably look like last week. But 2 weeks ago, if I don't want to rely on just one number, I could average the last 2 weeks or the last 3 or the last 5 weeks. If I'm averaging the last 5 weeks, I'd still think the number I sold last week is probably a better indicator than the number I sold 5 weeks ago. So I might want to work out an average where I give different weights and I give more recent information more importance than older information. And in a lot of forecasting and time series analysis, we do that. We give more importance to recent information and less importance to old information. But from within this course and most of statistics, we treat every value as being equally important. Now, an alternative to the average is the median. So in this data set, we knew there were outliers. There were some that gave very, very high salary figures. Maybe we don't want to believe them, or we're going to say they're not indicative of students in general. We're trying by finding the average salary to describe expectations of typical students, not the extreme values. So maybe I'd like to ignore ones at the extremes. And there are methods for doing that of just snipping off the numbers at both ends and averaging the ones in the middle. I do that all the time. But a more popular approach for dealing with that is the median. So with the median, I'd take my numbers and I'd sort them from smallest to largest. So the smallest salary figure was probably a 0, and the largest, as I recall, was 650,000. So I'd take this great long list, and then I'd go down the list to the middle of it. So 752, it's going to be 375, 376 numbers would be above the median, and 376 values would be below the median. So what's that number that's right in the middle? That would be the median. If you use the total row, and let me just show you that. I didn't last class. So here are these values. So I could go and do it different ways. I could go and do it sort it smallest to largest. So it's going to go 0, down, 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 down. And I'll go down halfway down the list. I said there are 352 numbers, so 376 is halfway. So it's somewhere around here, 50,000. That'll be my median. If you wanted to do it by looking at the total row, do I still have that? Okay. So down here, and if I look at this, it doesn't have median. It has average. We did that one before. That's the mean. And it's got a bunch of others, but it doesn't have the one I want. So I could go and I can look under the statistical category, and I could scroll down, and it's got lots of different things here, doesn't it? A lot of functions. There's median. Of my whole list, okay. There, it gave it to me. I haven't done that before. But so I can do that with my total row. I can find it. I'll show you a different way of doing it in just a moment. So let me get back to my slides. Where did I leave you? Here's my slides. So I can find it that way. So what I did was I sorted the salary column. The blank guys are all down at the bottom. And I went halfway down. And now, if I go 376 from the beginning, I get 50,000. And then if I go from the bottom, I actually get a different spot. The middle is in between the two. Simplify. If I had 10 numbers and I wanted the middle, I'd go down 5, or I could go up 5. So between the 5th and the 6th value, I'll find the middle. And so I could average the two. In this case, they're both the same. And in this instance, both the numbers look roughly the same. 50,000 is the middle, or 53,000 is the middle. Why do we need two numbers? So I got a question for you. Why would we use one instead of the other? Or why would the numbers be very different from each other? I got numbers that were almost the same. If I'm looking at the middle, shouldn't they normally be the same value? They're okay, different calculations. Since different calculations are going to get different answers, but they're not very different from each other, not by a lot. It's not like one gave me 40,000 and the other one gave me 55,000. That would be a big difference. Any thoughts on why I'd use one instead of the other, or probably use one instead of the other if the numbers were very different? But why would I look at ones in that fashion? Any thoughts? You can type into the chat if you can't get the discussion thing working properly. Hopefully it does. Is anybody typing? Does it work? Did I set it up right? Nobody wants to take a chance? Oh, there we go. Outliers, yes. It'll include the outrageous numbers, and that'll distort things. That a And that's generally the concern, is the extreme values. And it's more when my data set is really skewed. So let me show you. No, it doesn't really tell me the distribution of the sample, because this is just telling me the distribution generally is talking about the whole pattern. Let me go back to Excel. So we did a histogram last time. So this is a distribution. A distribution tells you about everybody. It's a frequency distribution or that type of thing. And so it's giving me the overall pattern to my values. And you can see that I've got some that were up at the top end, and these ones went, as you said, very outrageous values. If my distribution is skewed, so this one is skewed, it's got a tail that goes off here on the right-hand side. If that's happening, then you will find the median and the mean are different. That the median is only determined by these values that are in the middle. Doesn't matter what the ends look like. The ends can be as high as or as low as you like. It's only going to be the numbers that are right in the center that will determine the median. So the median isn't affected by outliers at all. And I don't get heavily skewed data. Now, if my numbers are wrong, I'm just making these up. But if you wanted to talk about what are typical salaries of people, earnings, annual earnings of individuals, that if we had their tax returns and had that income information, and we wanted to know what's average, what's middle. You may hear the expression middle income. What is middle income? That lots of people like to say they're middle income. They're just average Joes. They're not rich people, but they're not poor people. They're just middle people. Well, if you took the average of all of them, you might get a value like $55,000, $60,000. And so the average across Canada might be $60,000 is the average income. But if I looked at the median income, I'm probably going to get something like 45,000. That's quite a difference between the two. 60,000, that's comfortable. 45, that's tough to get by. But they're both middle. The median is much lower than the mean because the mean is being distorted by those people that are earning hundreds of thousands of dollars a year. The top 1% of people, those that earn $1 million or $5 million, that CEOs of large companies, that those high income people are out here in that right hand tail, and that tail goes for a long distance, and they really distort the average. We didn't see it in our sample because we had a bunch of people giving us crazy numbers that were crazy low. They were giving us zeros. That we don't have that many people that have zero income, that they may be on social assistance, they may not have a job, that, but they've got some sort of income. Maybe it's only $8,000, $10,000, $12,000 a year, but there is some money there. So back to my slides. Let me slip this down. There we are. So you are going to get different sorts of results that are going to be showing up. So as you said, the median isn't affected by outliers. But in practice, when we talk about what's the class average, you mean the average. You mean add up all the numbers and divide by the number of students in the class. It's the most common measure of the middle. But in certain fields, particularly economists, when looking at income, will very often do their analysis based upon the median income instead of the mean income, because the median is a better indicator of what most of us think of as the middle. But also, if you got your grades back and you got a high grade, you'd like to know how high am I at the top of the class? Unfortunately, you don't want to know if you're at the bottom of the class. what is, if we talk about people that have high incomes, what does high income mean? A common expression that's been used for the last number of years is the top 1%. Those people that 99% of people earn less than these individuals, only 1% earn more than them. So they are the super rich. What is super rich? What's the cutoff to be in the super rich? Is it $200,000? Is it 500,000? Is it $1 million? I don't know. But that may be what we want to use. Some might find top 1%, that's too small a group. Maybe the top 10%. What's it take to be in the top 10%? What's it take to be in the top 10% of the class? Some European universities, an A, they will grade on a curve, in a sense. You only get an A if you're in the top 15% of the class. So if you're in a smart class, it's harder to get an A than if you're in a stupid class. So your best thing is to take classes with people that are not as bright as you are, and you're going to get a better grade. You look better. Doesn't make sense, but that is a common practice in some European countries. I'm not sure about other countries. So how do we measure high? How do we measure low? And so if I was looking at 1%, 1% of 752 students is 7.5. So let's say it's the 8th largest salary. So I counted back from the top. I sorted smallest to largest, count back 8. I got $175,000. 10%, that's counting back 75. That may be hard to do, count backwards. So maybe if I went forwards, it means if 10% or more than 90% or less, 90% of 752 is 677. So I could have gone to my spreadsheet, and I think I've still got them sorted here. Smallest to largest, do I? Hold on. Boom, 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 boom. Where are those? Oh, that's right, because they're blanks. I got to go up. So there they were, smallest to largest. And so if I go up to 677, I get 80,000. So is 80,000 an indicator of high salary, that 90% or less than that? And I've only got a small percentage that are more. So I could say that 80% is a high salary. We give these names percentiles. If 90% are smaller, then it's the 90th percentile. If 10% are smaller, it's the 10th percentile. So the 10th percentile would be down at the very, very, very bottom. The 10th percentile in this data set, where was I? I would have looked at number 75 in my list here. 10th percentile was only 25,000. So maybe 25,000 is my measure of low, and 80,000 is my measure of high. Get these guys back in order here. That minimum and maximum are not good choices for low and high. Percentiles are better. But it's subjective. If your measure of high is the top 1% or the top 5% or the top 10%, somebody else may have a different cutoff. They may say, no, the top 20% is fine, or it's maybe the top 25%. And that leads me to the next one. If I want a really simple way of doing things, and we're going to use this later in the course in another week and a half as a quickie way of summarizing data, if the median splits it in half, then maybe I'll take the bottom half and split that in half. And so if you're, and I'll take the top half and split it into half. So I actually split my data set like taking a pie and cutting across one way and then cutting across the other way, and split it into 4 quarters. And the 4 quarters are called quartiles. The bottom 25% is the first quartile, and then the next 25% are the second. The next 25%, so they're just a bit above the median, they're the third quartile, and the very top 25% are the fourth quartile. So they're above sorry, they're called the fourth quartile. That's they're the fourth quarter. That this is common when looking at trying to do comparisons between groups or among groups where we've measured things numerically and we'd like to compare the low performers to the high performers, or the low income ones to the high income ones. That if I was studying students and trying to look at success and lack of success, and I wanted to examine the students, instead of looking at all the students, look at the bottom 25% and look at the top 25%. And are there things that we know about the top 25%, about what they do or what is affecting them or interfering with their lives, or what their income is, or where they're from, what their background is in some fashion? And look at the bottom 25%. What do we know about them? And are there things that we can learn from the top 25 that can help us improve services to the bottom 25, and bring that group up? That's common in studying economists when looking at household income. They look at the top and the bottom, the most and least. The other thing we like to look at times is diversity. How spread out is my data? So I've got lows and highs, but do I have quite a broad mix of people? Or are they all very, very, very similar to one another? So the simplest measure might be the range. Let's take the maximum value, subtract the minimum value, and see how big a gap there is. Well, our maximum value is 650,000. Our minimum value is 0. Having a range of 650,000 doesn't tell me anything about studying the diversity of the students that reported incomes. And it just tells me about the outliers. It doesn't tell me about the rest of them. So I'd like to talk about the typical individual, and maybe, are you above average or below average? Are you a lot above average or a lot below average? Do I have lots of people above average and lots below average, or lots that are far above and lots that are far below? That How do I come up with something here? Like if I was looking at the mean, okay, 53,000 approximately. 20,000 is about $33,000 below the average. 65,000, these are just numbers I picked. It's about $12,000 above the average. So 20,000 is quite low relative to the average. 65 is a little bit high compared to the average. But I really don't care about positives and negatives. I have a typo here. This shouldn't be the mean average deviation. It should be the mean absolute deviation. I've got to fix that. So I could take absolute values, take all those negatives, take each number, subtract the mean to see are you above or below the average and how big a gap it is, but remove all the minus signs and average the numbers out. And we get this thing called the MAD. It used to be very commonly used before we had computers, which for me is still, I can remember that, where everything had to be done by hand. It was much easier to do by hand than some other measures. And it's still used in forecasting. We'll sometimes talk of my forecast of sales next week My best guess is that we're going to sell 1,200 units, but I might be off by 200 either way. On average, my forecasts are in error by 200 units. And so they use that type of thing. It's a very simple, crude measure, but it's easy to understand. It's easy to communicate, but nobody uses it. And sometimes I say in forecasting you'll see it, but nobody uses it for measuring diversity generally. They like coming up with other things that have nice theory and nice mathematics. And generally, mathematicians don't like absolute value. They like squaring things to get rid of minus signs. So if you take -2 and square it, you get +4. If you take 2 and square it, you get +4. So if you're 2 above or 2 below, you're still the same distance away. So if we take the difference and square it, we will be able to get that measure. So they have a formula for it. So take each value, subtract the average, do that for each of the values, square them, then add them all up. I don't think I explained to you before. This squiggly thing here means add up all the numbers and then average them. But we're going to divide by 751 instead of 752. Why? There's some theory behind that. We tend to bias our results by dividing through just by the sample size. So they get this thing and they call it the variance. And if I did it for my data set of those salaries, I'll get something like 1,970,000,000. It's a huge number. And they're square dollars because I squared everything. What's a square dollar? I don't know. How do I interpret 1,970,000,000 and so on? I can't. So what we do, we take a square root to get the square dollars back to being just dollars. And this thing is called the standard deviation. Seems like a lot of work, and it is. I'd ask you never have to do it by hand. This is painful to do by hand. That's why we have computers. And you can understand why in the past we didn't like to do it by hand. We even had to do square roots by hand. That's not pleasant stuff to do. So this is far and away the most common measure for it. And in this data set, it would end up being $44,000. Now, I think I've got myself a discussion coming up, but I'll show you I could get it. Is that the one? Yes, here we are. If I went, and I've got my salary figures here. If I went down to the bottom here, where I've got my total row here, and did that arrow again, I could get it by just, here's the variance. Yick! It's really, really big. Doesn't want to give me the number. It writes it in scientific notation. There's the standard deviation, $44,000. What am I going to do with that? What does it mean? What does it really represent? I don't know. So it's confusing but it is the single most commonly used measure of diversity in a data set. How do we use it? What does it represent? What is this $44,000? I understood what the $53,000 was for the average. So why would we want to measure diversity in the first place? And then how? Sorry, my keyboard, the letter H, the key is sticking and it doesn't appear. So that is, how would you explain a numeric measure of diversity? This one happens to be $44,000. Even any other number. Do you have any sense of how you would explain what a number measure for diversity? Does this tell me that there's a lot of variability among students in what they expect to earn at graduation? Or there's not much diversity in what they expect to earn? How would I interpret this? Does this number make Does it tell me anything? Um, I took each of the values, I subtracted 53,000, I took those differences, squared them, added them all up, averaged them out, then took a square root, and I got 44,000. What is that? That everybody uses it. What is it? And you're going to ask all the people that use it, and they probably won't be able to give you an answer. Uh, do you have any thoughts on it? And it's okay if you don't. If it's just confusing, welcome to the club. I've been doing this for a very long time. I still find it confusing. And I know all the theory behind it. It's still confusing. Any thoughts? In a discussion, it doesn't tell me whether or not anyone's typing. Go another second or two. No. Okay. I'm going to jump ahead. Sorry to cut off someone that might be taking. Oh, there. I guess it would give a pretty solid idea of what? Of what? What is it? Uh, how different things are. Yeah, but what does 44 tell me? I don't know. How do I use that number? I can picture the 53. Okay. Whoops. Okay. That was just a reminder to put that discussion question in. That so I get the 44. How do I use it? That the way the best way to use it is a very crude rule called the empirical rule. It works on some data sets, doesn't work well on others. Um, but when it works, it's very useful. So what it says is if my data was bell-shaped, like a normal curve. No, it doesn't work well here. Let's just go back and check it in this guy. Here is, where am I here? Here's my histogram. So this isn't, it's sort of bell-shaped, goes up and down, and if it stopped right here, it would be fine. That would be bell-shaped. But it's got all of these ones out here, so it's not going to work well. So if I could chop off the ends, maybe even chop off some of the stuff that's down here, this rule will work. But the way I've got it right now, it's not going to work properly. But let's get back to it here. Yep, get in my way. Okay. So if it did, then approximately 68%, approximately 2 out of 3 values would be between the mean minus a standard deviation and a mean plus a standard deviation. We'll work out the numbers momentarily. And almost all the values, 95%, 19 out of 20, would be between the mean minus 2 standard deviations and the mean plus 2 standard deviations. And we shouldn't see almost any values that are more than 3 standard deviations away. You might get the odd one, but not often. So how does this help me? Well, if I do it with these numbers, it doesn't because I don't have a bell shape here. That if I go from 1 standard deviation away, I'm going from about $9,000 up to $97,000. That's going from a really, really low number to an awfully high salary. And if we went back and looked at our data set, we're going to get more than 2 out of 3 values in that range. That's not working. And if I went out 2 standard deviations, so imagine taking another 44,000 away from this, you're going to get what, minus 36,000 or something. And if I went 44 above here, I'm getting like 140,000. These are very, very bizarre values. They're I said silly results. Doesn't work. And so if I think my data is highly skewed, if there's a long tail, it's generally a long tail to the right, this rule won't work well. But if I cheated and I went and clipped the ends, so what if I went and took out the ones below 10,000 and the ones that are maybe above 120 or something like that, and took the ends away, and then went back and did my calculations, what would happen? If I went and trimmed out those values, the standard deviation is almost the same. It's around 50,000. That sounds better. It's more like the median, right in the middle. And the standard deviation changes a lot. A standard deviation is very, very much affected by outliers. If you think the mean might be affected, it's nothing compared to the standard deviation. The standard deviation, remember, we're squaring things. So we would take 650,000, subtract 53,000. So we're still looking at almost 600,000. Squaring that number, that's big. And it's going to contribute a huge amount of pull to making that standard deviation bigger. So my standard deviation shrinks from 44 all the way down to 20 just by trimming out the odd values. And so going at one standard deviation would be from 30,000 to 70,000. And if I look at my data set, probably 2 out of 3 students reported expecting to earn between 30 and 70. That was quite reasonable. And if I go out 2 standard deviations, I'm going from about 10,000 to 90,000. And that's almost all the values that were really clustered into that sort of range. So that makes sense as well. So when it is bell-shaped, the rule works. When it's not bell-shaped, the rule doesn't work. But it's attractive because then I can say a very low income is 10,000. A low one would be 30. The middle is around 50. High income would be about 70, and a very high income would be above 90. So just knowing 2 numbers, I can summarize what is low, what's high, what's in the middle, what's very low, what's very high. So the empirical rule is a very useful, simple tool. We call it a quick and dirty tool for helping us define those important landmarks. And those are generally the ones that we think of as being the most important in getting a sense of a data set. And we think of diversity not in terms of a number, but probably in terms of 2 numbers. That where is the middle group? Oh, they're from 30 to 70,000. Oh, okay, they're not that spread out. And everybody else is between 10 and 90. Oh, okay, maybe there is a lot of diversity in my data set between the really low ones and the really high ones. But our picture of diversity isn't 1 number, it's 2. Between low and high, or very low and very high, depending upon how you want to do it. So by knowing the mean and the standard deviation, if my data set is not highly skewed, this is very, very useful stuff. Now I can do all of this stuff in Excel, and I can do that using that data analysis tool. So let me go back to Excel. Where are you, Excel? Boom, there we are. So let me bring this up a bit. Go back to my data set here. And so I could go up here to File. Oops, I already did that. That's right. I showed you last class how to get data analysis in. So if I go to the Data tab, if you missed the last class, go back and watch the video, or the very first one that's embedded in your in chapter 3. Go to a data analysis. Okay. Now, I get another little pop-up window, and I can't make this bigger for you to see, but we used a function called histogram before, and now we're going to use one that's called Descriptive Statistics. Click OK. And you're going to get the stuff from the previous class. Let me take them out. That's all I need to take out right now. We'll take this out too. That normally it comes up in this fashion. I'm going to go find my data. Oh, there it is. My salary data is here. I've got it sorted, but it doesn't matter. It doesn't. So my input data is all in this column M here. So I'm going, excuse me, from M1 all the way up to, I'm going to go to, I could go to 812. It'll ignore the blanks, but I'm just going to go to 752 because that's where the last number is. But it should take, do it to 812. Let's make sure it doesn't do something silly to me. So this would be everything in that column, including the blanks. My data is all in columns. Okay? It could be that my table is flipped around so that it's numbers across that I want to look at. But so I would click rows in that case. Here I've got columns. I've got a label in my first row. I've got salary. And I always recommend you put it into a new worksheet. And I want summary statistics. There are other things I can get. I don't want those. And click OK. There we go. It did work. So let me make this bigger so you can see it. There we go. So there are a bunch of words here, a bunch of numbers here. I can't see all the words, so I'm going to make this wider. And you'll notice here's this super big number. Even that one's a big, big number. So Excel puts things in scientific notation when it's a really big number. But if you give it more room, it'll spread those things out, show me all the digits. I'm going to go here and put commas in. Oh, I'm going to make it a little wider here. There we go. And so this makes it easier for me to read. And this is where I got the 1,940,000, lots of numbers, and even a decimal at the end. That sometimes students ask me, how precise should my answers be? Most of the time I don't need any decimals. That even with this mean here, it's got too much information for me. If you just told me it was around 53,000, that's good enough. Most of the time we're not trying to measure things with that type of precision. This isn't a laboratory experiment where I need to do those types of things. I just want to know what ballpark I'm in. So this is the mean that we calculated before, the median that we found previously. What's this one, mode? Mode is one I don't like. The mode is the value that occurs the most often in my data set. Now, because the students were rounding off their answers, and if we looked at this data here that we had, you'll notice that they round out the numbers, and there's lots picking 20,000 or 25,000 or 30,000 and so on. Lots picking 40 and onwards. They aren't picking 41,213. So I will get values that are being repeated. And the mode would be the value that's repeated the most often. But generally, if I'm measuring numbers, it's, and I look at all the digits, so if I was worrying about the precise numbers, that they almost all look different from each other. Maybe not by very much, but they're different from each other. And the mode ends up being a meaningless number. The mode, whoops, excuse me, why did you move? In a histogram, see where it peaks here? It peaks around the 50,000 mark. That's the mode. The mode is where the peak would be if I had this as a graph. But as a single specific number, don't fuss about it. Ignore it. This is the standard deviation I calculated. This was the variance that I could calculate. What's kurtosis? If I look at a histogram, generally it goes up and it goes down. How fat are the tails? Does it go up very slowly and then down slowly? And the difference between how fat it is here and how much it is here look very similar? Or does it go up rapidly and then down rapidly with skinny tails? That the kurtosis is a number that measures how fat the tails are. I don't know what 97.24 looks like. Just look at the picture. And there are certain types of data sets where we do get these fat tails, and that complicates certain types of analyses. Don't worry about it. You won't encounter it. Finance encounters it in some of the data they analyze. Skewness is, we've talked about skewness. It's, does this have a long tail to the right or a long tail to the left? That rather than giving that a description, we give it a number. But most people, when they see the number, just can't picture it as to what it represents. Just like when looking at standard deviation, it's hard to picture that as a measure of diversity, that it's easier to look at a picture. And I'd recommend that for these two things. Don't worry about the number, ignore them. Look at a picture and talk about the picture. The range, that's the largest minus the smallest. My largest was 750,000. My smallest was a blank or 0. If I added up all the values, I would get 39 billion. And the average is 39 billion divided by the 752. So this gives me a simple summary report, probably more than I really need, but it's quick and easy to do. So, oh, but what about this one? Standard error. Didn't mention it. This one is really useful, and it's something that we will use various times during the term, and it's one that takes a while to understand. It's going to be like standard deviation, which is very hard to understand. Standard error is harder to understand. But it turns out to be a very useful measure, and it's one where it's not important is my data skewed or not skewed. We're going to come up with rules that we can use almost all the time as long as we've got a reasonably large data set. And so did all those things. Oh, when I do a survey, I go out. In this instance, there were about 7,000 students that were invited to participate in the survey. 752 did participate. And out of the 752, I got an average of 53,000. That if I did another survey, or if I could get 752 other students to go and tell me what they expected as a salary, would I expect the number to be different? I want to generalize this to talk about those 7,000 students. Should I be worried that I've only got 752? I don't have all 7,000. But if this was a representative sample, that what could I say about all the people that didn't participate? What's the average for all students together? Or what can I say about other estimates I might see? So, and this becomes an important issue when we have to defend our analysis and talk about how accurate our answers are. We got a mean of 53,000. Is that accurate? Or even if it was 50,000, is that accurate? If I took a different sample, I'm going to get a different answer. Would it be a lot different? Would you be surprised if your average in a different sample was 60,000 or 70,000 or only 35,000? Or would you expect it to be almost the same? How different would it be? What would make my answer a lot different? What would make it really similar? That any thoughts on that? Because we see numbers reported all the time. Should we believe them? Because they're almost always based upon a sample. That they will often hear mention of a term called margin of error. And it's an indicator of how far off our estimates might be, because generally we are working only with estimates and they're not perfect. So how can I work with imperfect data or imperfect estimates if that's the only thing that I've got? I'm going to have to work with it, but should I trust the numbers? Should I put too much? Yeah, I'm going to get a completely, what you mean, a completely different, and the 7,000, you would think it would be a higher average. Why would it be higher? Why would it be higher than the 752 people that I did get? Um, so we do have issues to do with, is it a valid sample? The ones that answered, are they different from the people that didn't answer? Yes, because they answered and the other people didn't. But if they were a truly random sample, so I um, uh, was, suppose I was looking at 7,000 students, and um, I had in the US, um, students get financial aid that's based upon tax records. And so if I wanted to find out about earnings of parents, um, that to give financial aid, and it is that case in the US, um, they could actually get the real information through the student aid system. So it's not just, and so if I, instead of looking at 7,000 students, and, if I wanted to take a sample of 752, if I randomly pick them out of the ones in my database, I could find what the real salary figures were for their parents, at least. That what, it's, I know it's only 10%, but does that matter? If there were 7 million, should that matter if I've got a sample? That they, turns out it doesn't. If it's a random sample, this one isn't random. Um, the people that answered the survey are different from those that didn't. So I can't generalize in that fashion. But if we've got a random sample, and that's what most of statistics is based upon, then it turns out it's quite different. That I could use the empirical rule. I could say uh, that of the estimates I'd get, most of them, 2 out of 3, would differ by about $1,600 from my figure. And almost all of them would be off by no more than $3,000. So if my estimate is 53,000, I could say that if I surveyed all 7,000 students, and presuming I did have a random sample, I think the average for the 7,000 would be somewhere between about 50,000 and 56,000. I could measure it that precisely. And even if my data was skewed, the empirical rule in this instance does work with averages when we're studying the precision of averages. Um, that, um, as you know, uh, I like going to a website in the US, just because they have some interesting reports on polling and surveys and that type of thing. That 538 is the name of the website, and they do a lot of reporting on elections. So at the moment, they do a summary of all the different opinion polls that are out there. And the most recent ones are giving Biden a roughly an 8% advantage over Trump. So they're saying that the percentage of people saying they'd vote for Biden is about 8 percentage points higher than the percentage that will vote for Trump. And that's typical in many of the polls. Now, some polls give a bigger margin for Biden, and some give a smaller one. They would say with a poll, generally an opinion poll that you see in the media that is based upon only 1,000 people, just 1,000 people, they'll say it has a margin of error that's about plus or minus 3 percentage points 19 times out of 20. Ignore the 19 times out of 20. That's that 95% in the empirical rule. So they're saying most of the time the poll results will not be off by more than 3 percentage points. So that 8% that advantage Biden has may not be exact. If we were able to survey everybody, it might be as low as 5 points. It might be as high as 11 points. So he's got a significant advantage at the moment. Mind you, if an election was held tomorrow, the margin of error could easily be much more than that. Trump would still have a bit of an advantage because Republicans are more likely to vote than Democrats are. That Trump's base is much more loyal than Biden's base is. Biden's base is a lot of people that want to vote against Trump. But it wouldn't surprise me if the Trump supporters turned out for the election in much larger numbers, or a larger proportion of the Trump supporters turned out than the Biden ones. And that we've seen in previous elections, that their pattern of behavior is different than what they give in opinion polls. But they talk in terms of margin of error, and we're going to be focusing on that because as we move forward, we're going to be estimating different things, and we need to know, should we believe our estimates? And what's interesting is it doesn't matter if you're surveying 1,000 out of 10,000 people or 1,000 out of 330 million people. It's actually how big a sample you have, not how big the population is that you're surveying from, that's important. You'll learn more about that in a statistics course. But it's still another good rule of thumb to have, that your estimates are generally between, don't be surprised if your estimate is off by 1 standard error, but it shouldn't be off by more than 2. So we've gone through looking at things like where's the middle, what's high, what's low, some of the most common measures that we've got for that. Some take a lot of work to calculate. Generally, we've got software to find these things for us. But interpreting them is occasionally difficult. Interpreting variability is very difficult to explain. So you have to think, it isn't just doing analysis, you have to communicate your results. And how do you communicate these things effectively? I use Empirical Rule. It's the simplest way. I use, to describe spread, I talk about high values and low values. I use those two ends and try to keep away from the technical jargon. You're going to lose your audience if you use that. So, and to be able to talk without using the jargon, you actually have to understand what you're doing. That don't get wrapped up in the mathematics and that type of thing. That's one of the criticisms I'd have of a lot of the way we teach statistics. As you get so absorbed in the formulas, you forget what you're doing. What I'm going to do next class is one of my favorite tools in Excel. It's really powerful. It's something that you should learn and learn how to use well, called a pivot table, and associated with it is a pivot chart. And we can do all kinds of different types of summaries and analyses of averages and percentages. We can create charts on the fly. We can switch them around. It'll make the stuff we've done with the descriptive stats and histograms seem very, very, very clumsy. And this is the tool you'd most often use. The other ones you'll probably use in a stats course. But in practice, use pivot tables and pivot charts. And this is where we're going next. Anyway, I'm running longer than I should. You'll see me in another 2 days. If you've got questions on the assignment, please send me an email. If it's about Excel, send me your spreadsheet. You take care, and we'll be back in 2 days. Bye now.